Alright, so we've just talked about the idea that just because we set up a system of equations does not necessarily mean that it has a unique solution. So again, we're going to go through how to actually check whether or not a solution exists by, again, the real, how you actually go through it is you check if the determinant of the square matrix is 0 or not. Okay? So I've set up three kind of levels of question. So this first one, part A, determine whether or not there is a unique solution. What we need to do, figure out what that square matrix is, find its determinant, compare it to 0. That's our process. So as we went through in class, when we've got it perfectly set up, isn't it nice? I've already set it up so that the x's are in line. Okay, so one's on top of the other, the y's are in line, and the constants are by themselves on the other side. So we've got 3, 2 as the coefficients from the first equation, and -1, 4 from the second. I'm just filling these in for completeness sake, but really it doesn't. All we care about is that square matrix. Okay. So we've set that up beautifully. Now what we want to actually check is the determinant of that matrix. So I'll give you a moment to think about how we find determinants. Okay. So the determinant of A, again, it's the product of the leading diagonal minus the product of the non-leading diagonal. So it's AD minus BC, and that's our formal equation. Okay. Take a moment, go through and actually do that calculation. Okay, so the determinant of A is 3 times 4 minus 2 times -1, which means the determinant of A, okay, 12 minus -2 will give me 14. Okay, happy camper, 14 is not 0, so there is a unique solution. As simple as that. Find the determinant. Is it 0? Yes or no? If it is 0, no unique solution. If it's not, okay, you've got a unique solution, but it doesn't actually ask you to find it here. Okay, so again here, filling in my coefficients, 2, -3, the coefficients from the first one, and 4, -6, the coefficients from the second one. Okay. Again, I'll fill this in for completion, but you don't really need to. All we care about is that square matrix, -12 and -28. Okay. So we're going to go through the same process. So I check that determinant. So in this case, my leading diagonal is 2 times -6, and my non-leading diagonal is minus -3 times 4. Okay, so going through that calculation, -12 minus -12, that's -12 plus 12, or 0. Okay, so -12 minus -12, -12 plus 12 is 0. So that means there is no unique solution. Okay, so in this case, we did get the determinant of 0, meaning there's no unique solution. If you were, okay, back in the day, if you had checked the gradients of these two lines, you would have found that they were the same, and then compared their y-intercepts, and they would be different, and they are actually, there's no solution at all. Okay, it's not just that it's non-unique. And then the last one, I was slightly meaner. Okay, I've given you the equations, but I haven't given them to you in that nicely lined up form, so you will have to do that. Okay. So the first one is 3x minus y is equal to +7 by adding 7 to both sides to rearrange that one. The next one I've got a little bit more to rearrange. Okay, so we move the 12 over. We've got -12x plus 4y is equal to -28. So we've done that by subtracting the 12x over to move it back over to the left. The 4y got to stay where it was, but then subtracting -28 over to the other side, and it, again, we are subtracting it. So we got -12x plus 4y is equal to -28. So in this case, 3 and -1 are the coefficients from the first one. and negative 12 for coefficients from the second one. Again, filling that in is just a matter of completion. So if you were to actually check, okay, what is the determinant of A? So the determinant of A is equal to 3 times 4, that's my leading diagonal, minus negative 1 times negative 12. Okay. If you actually do the calculation, that tells you that the determinant of A is 12 minus, again, negative times negative is a positive, so we do get, again, that the determinant of A is equal to 0. Okay. We don't need to know anything else. As soon as we find out that determinant is 0, we can say there is no unique solution. In this case, it would be the other scenario. There's actually an infinite number of solutions because these two lines are directly on top of each other if you were to graph them. Okay, but again, for us, for our purposes now, that means the same thing. There's no unique solution, so we're just saying there isn't a valid answer that we're going to consider. We can be a little bit more abstract in the types of questions we ask. So for example here, example 2, for what value of x is A equals 3x to 4 a singular matrix? Okay, so again, this is where the terminology really comes into play. If you don't know what a singular matrix is, okay, you can't answer the question. Okay, remember, this is the error that the CAS will give you, that if you do try and find the inverse of a matrix that doesn't exist, it will tell you that it's that it is a singular matrix. Okay. So, singular matrix means the inverse does not exist. Okay, so what this is really saying is find the value of x so that det of A is equal to 0. That's really what it's asking. Again, you need to know that the terminology singular matrix means a determinant of 0. So it's saying for what value of x is that going to be 0? So we set up a little equation. Well, the determinant of A is AD minus BC. But we also know the determinant of A needs to be 0. Okay. So let's just maybe write 0 is equal to AD, 3 times 4, minus BC, which would be x times 2. Simplifying that equation, we would get 0 is equal to 12 minus 2x. Now we're just doing good old algebra, rearranging for x. Adding the 2x to both sides, we would get that 2x is equal to 12. Dividing both sides by 2, we would get that x is equal to 6. Okay, which does answer the question that for what value of A, or what value of x rather, is A a singular matrix. You can do a quick double check. If you were to multiply the leading diagonal, you would get 12. We also would want to get 12 along here because we're subtracting, and putting a value of 6 in there does work. Okay, so that's two types of questions. First, just checking if it is singular or not, to state if there's a unique solution or not, and then a little bit more abstract, being able to use the definition and a little bit of algebra to answer some questions.